Welcome back to my channel. So today I am going to discuss diode, its working and characteristics. Diode is formed using two words, that is die plus electrode. This means that it uses two electrodes. It contains two electrodes. One is anode and another one is cathode. Here anode is connected to P type of diode and cathode to the N type of diode. So what are P and N type here? I have already made a detailed video on P and N type semiconductor. So if you want a detailed explanation, please must watch that video first. But for now, to have a basic understanding, P-type is formed when intrinsic semiconductor is doped with trivalent impurities, and N-type is formed when intrinsic semiconductor is doped with pentavalent impurities. Now what are trivalent and pentavalent? Trivalent has 3 electrons in outermost shell and pentavalent has 5 electrons in outermost shell. P-type has holes as majority charge carriers and electron as minority. Similarly, for N-type, electrons are majority charge carriers and holes are minority carriers. So now moving forward, I have taken two bars here. One is P-type and other is N-type bar. P-type bars has more of these carriers which are holes, and we can see these are in majority, and this filled circles or filled one are electrons. Similarly, in N type, these filled ones are electron and these vacant one are holes. Holes are nothing but considered as a carrier which is devoid of electron. Okay, these are nothing but a positive counterpart of electron which has charge as electron. Now what we have to do, we have to combine these two to form a diode. Before moving forward, let me tell you little bit about its energy band diagram. In the energy band diagram of p-type semiconductor, this is conduction band and this is valence band. It has one energy level which is called acceptor energy levels, which has holes in majority. Since it has holes in majority, so it forms a acceptor energy level near valence band. Similarly, for N-type semiconductor, it has a donor type of energy level which is near to conduction band. Now what happens if we join these two semiconductors? It will form a diode. So let us see what happens next. So as we attach or we join these two type of semiconductors, P and N type, then a process called diffusion takes place. What is diffusion? A process in which carriers move from high concentration area to low concentration area. What does that mean? We can see that holes are majority, they are more in number in P type, less in N type. So these holes will start moving from P type to N type. Similarly, electrons are more in N side, so these will start moving from N side to P side. So in this way, this diffusion is taking place here, where electrons move from N side to P side because they have high concentration in N side and less concentration in P side. Holes will move from P side to N side. During this process, they start recombining. At this junction point, this is a junction point. Let me explain you using a very simple example. Say there is one atom. It has a hole in it attached to it. Now if we try to take away this hole from it, what happens? As I already told you that this hole is considered as a positive charge. So when we take away its positive charge, it will start behaving as an ion with negative charge. Similarly, if we take away this electron from it, then it will convert to an ion with positive charge because its negative charge has gone. So it will attain a positive charge. This is said to be positive ion and here it is said to be negative ion. So as these holes and electron they start recombining, Then these holes from P side are moving towards N side, leaving behind a negative ions. As more number of holes cross the junction, more negative ions will be left behind in the P side. Similarly, as electrons move from N side to P side, they will leave behind some positive ions. As this process continues, this is the case what happens. Here in the P side, these negative ions will be left behind, and in the N side, positive ions will be left behind. As these negative ions start building up on the P side and start accumulating at the central junction region, they will start repelling the electrons towards N side. These positive charge on the N side will repel the holes towards P side. So they will stop further movement of these carriers across the junction. So no current will flow. And this is said to be the state of equilibrium. And this junction area where these charges are accumulated is called depletion region. Why depletion region? Because this area is depleted of charge carriers. No charge is present at this area. Only ions are present which are immobile. This is the case of equilibrium. What happens in the equilibrium case? Then these acceptor energy level and donor energy level, they get aligned. This height is very large such that the carriers cannot jump from this area to this area. That's why this is called depletion region, or we also call it as base charge region. This V naught, some typical value which is equal to, this V naught is equal to 0.7 for silicon and 0.3 for germanium. Only when some external supply is applied which will overcome this potential, only then any further movement of electrons or holes, these carriers, will be allowed. So now what is forward biasing? Forward biasing means, this is P type, this is N type. Forward biasing means connecting P side to positive terminal of the battery and N side to negative terminal. Similarly, this is the condition when equilibrium has reached and I have applied in some external potential to it. As soon as we connect this battery, this negative side, this negative terminal which is connected to N type will repel the electrons from it and will push it towards the junction. Similarly, this positive terminal will push the holes towards the junction. In such case, these ions will start disappearing because some electrons will be consumed by these ions. Similarly, some holes will also be consumed by these negative ions, and this depletion region will start reducing. And this is what we get. As it crosses the barrier potential, current will suddenly increase, and this is current voltage characteristic we get. This Vt, this is the threshold value which I have already told you that it is 0.7 for silicon and 0.3 volt for germanium. So as soon as this voltage is crossed, only then these carriers will be able to cross the junction and conduction will start. Before this Vt, only very small amount of current can be seen, but after this there is a sudden increase in current. Now what is the direction of electrons, holes and current? Electrons are moving in this direction from N side to P side. Holes are moving from P side to N side. Current always has the direction opposite to the direction of electron. So current will move from P side to N side. Holes direction and current direction is same. Always remember that conventional current direction is always reverse of the electron direction. Now next case, reverse biasing means connecting negative terminal of the battery to P type and positive terminal of the battery to N side. Here also, this positive charge will try to attract the electrons from here. Here, this N terminal of the battery will attract the holes from here, and it will pull these holes away from the junction. So as this happens, more ions will be start accumulating across the junction and this depletion width will increase. Now as the depletion width is increasing, no further movement of electron will be allowed. So this is the characteristic we get, although we are getting a very small amount of current here, which is called as leakage current. This leakage current is basically due to minority charge carriers. Some of the minority charge carriers from the p-type and n-type, they will somehow manage to cross the junction, and due to this very small amount of current will flow, which is called as leakage current. But this is not substantial value. This current is due to minority, so here electrons are being pushed from this negative terminal. Very small value will be, a very small number of electrons will be there. So here electrons are moving from p side to n side, holes are moving from this to this. So what will be the direction of current? Opposite to that of electrons. So this is a complete characteristic curve of diode. In the forward biased, the current starts increasing only after it crosses this threshold value, and similarly in the reverse direction only a small amount of current will flow. Of course, particle voltage is crossed in the reverse bias also, it will cause breakdown in the diode. So even in those breakdown region, it has few applications, and I have already made a video on those breakdown in diode. So if you are interested in knowing its application, so please watch that video also. I'll add the link of both semiconductor and this breakdown in diode video link in the description. So please watch. I hope you like the video. So please like and subscribe. Thank you so much. Bye and take care.